What's up mga ka-Axis? In this video, I'll be discussing the degrees of freedom of a Cartesian manipulator. What is degrees of freedom? The degrees of freedom is defined as the minimum number of independent parameters, variables, coordinates needed to describe a system completely. It refers to the freedom of movement of a rigid body in three-dimensional space, including movements along the Cartesian plane and rotations on the x, y, and z axes. Objects can have varying degrees of freedom, and this is important in manufacturing and automation. In solving DOF, we can use the Grubler's criterion for degrees of freedom or mobility. Let us use the variable n as the rigid moving links, m as joints, and c sub I as the connectivity of the each joint. Since this is a PPP Cartesian manipulator, we will use the formula m is equals to 6n minus the summation of I is equals to 1 to m of c minus c sub I. Let us first count the number of joints. Let us use the variable m. Then let this be 1, then 2, and then number 3. Now let us count the number of moving links represented as n. This will be number 1, then link 2 and link 3. Now we have a total of 3 joints and 3 moving links. Then let us obtain the number of degrees of freedom, which we can refer from this table. Since our manipulator is a PPP Cartesian manipulator, we will choose the prismatic joint, and it has 1 degree of freedom. Now, we will obtain the number of constraints. This right here will be 6 minus 1, and since all joints are prismatic joints, all will be 6 minus 1. Now, we have all our values. Let us substitute it to our formula. Then we will have 6 times 3 minus 6 minus 1 plus 6 minus 1 plus 6 minus 1. Then the answer will be 18 minus 15, and which is equals to 3. Therefore, this is an underactuated spatial manipulator with 3 degrees of freedom. That is all for this video. I hope you understand the degrees of freedom for this Cartesian manipulator. And I'll see you on our next video.